Question number 3 says if 1200 centimeters or square centimeters of material is available to make a box with a square base and an open top, find the largest possible volume of that box. So we're going to start with the idea that we have a square bottomed box with an open top. So here's my box. It has open top, and we know the bottom is square, so we're going to call the length and the width both x. Now, what we don't know is whether or not it's an actual cube, so we have to call the height a second variable. So let's go with y. So now, the things we know about this are that we have 1200 square centimeters to make the box, and we want the largest volume. So the volume of this box is length times width times height, and we want the largest, so we're going to maximize that. Now, the surface area is what we're looking for this box when we have the 1200 square centimeters. So the front of the box is x times y. That's also the back of the box. So we're going to have two xy's for the front and the back. It's also the left and the right side of the box. So all four of these sides around the box are going to be xy's. So it's going to be a total of four xy's. And then the top and the bottom are x squared. We don't have a top, so just one x squared. And we know that equals 1200. So what I'm going to do is solve this for the easier one, which in this case is y. So what I'm going to do is say that y is equal to 1200 minus x squared over 4x. Now we can simplify that down a little bit. This is going to turn into 1200 over 4 is 300 over x minus x squared over x is x, so x over 4. So that's my y value. What we're attempting to optimize is x times y. So I'm going to multiply this 300 over x minus x over 4 times x squared to get my function. So that's going to become 300x minus x cubed over 4. And that can be my function. Now, from there, we're going to go ahead and find the derivative. So if that's my function, my derivative is pretty straightforward. It is 300 minus 3x squared over 4. We want to know where that equals 0 or undefined. It's never undefined, so we're going to set it equal to 0 to find my critical values. So my critical values are going to occur when 300 equals 3x squared, or I'm sorry, 3/4 of x squared. Multiplying that up, 1200 equals 3x squared, or x squared equals 400. In other words, x is plus or minus 20. Now it can't be negative because it's a length, so my answer is going to have to be 20 for x. Now, there's two things we need to do. We need to find the largest possible volume of the box. So that means we need to find y and finish the dimensions, and we need to justify our answer. So if x is 20, y is 300 over x minus x over 4. So y is 300 over 20 minus 20 over 4. Well, 300 over 20 should be 15. 15 minus 5 is 10, so y is equal to 10. So that means my volume is 20 times 20 times 10, making it 4,000 cubic centimeters. That's going to be the answer to my question. Now we need to justify. So to justify my answer, we're going to take the second derivative. If that's the first derivative here, the second derivative becomes pretty simple. The second derivative is just negative 3 over 2x, which means at 20, it becomes negative 3 over 2 times 20, which is a negative number, which is concave down. which makes A maximum.